I think it's very exciting, to have DNA now from about 400,000 years ago from human fossils really starts to open up a whole new area of interest, that we're talking about humans that are much further back in time, that are much more distinct from us, where we are heading back, in a sense, towards our common ancestor eventually with the chimpanzees, and that could be 5 or 6 million years ago. So 400,000 years is still not a huge time, but it takes us back a step further back from the data we've had so far. If we can get not just mitochondrial DNA, but the DNA from the rest of the genome, we really can build up a very full story of these earlier stages of human evolution, which so far we haven't been able to do. Well, what's intriguing is that, of course, the fossils from the Cima de los Huesos are thought to be early Neanderthals. So we would have expected the mitochondrial genome of these people to be related to that of the Neanderthals who come later. Interestingly, the genome actually resembles more closely the genome found from Denisova Cave in Siberia. Now that's very unexpected. Siberia is a long way from Spain. So it already suggests that we have a more complicated story, and what may have happened is that there was a lot of mitochondrial DNA variation early on, maybe 6, 7, 800,000 years ago. That variation has disappeared from the modern human lineage, and it disappeared from the Neanderthal lineage after the time of the Cima fossils, whereas in the Denisovan lineage, that ancient mitochondria carried on until the last 50,000 years. So we see already that we've got a kind of more complicated story coming out from having this mitochondrial DNA from 400,000 years ago.